Hello friends, welcome to follow up. In the previous video, we solved the problem 3599 using dynamic programming, but with tabulation. So this is the solution and the analysis, right? So we get into the final details in the previous video. So now I'm going to delete all those things and then do another solution format. So here I'm going to use recursion. So essentially we are going to present the same solution as the previous video, but this solution is shorter and it might be more preferred for some people which is who are very familiar with the recursion and also do a lot of cache or practices. But the previous version, I guess, is more beginner friendly. So here, first I'm going to make some change. I'm going to change this one to be A and this one to be K, just for convenience. So I'm not going to go through the problem statement, but if you have difficulty in practice this problem, you can look at the hints. Essentially, I'm following these hints, right? So first, I'm going to get the length of this nums list. Here, I change it to be A. So that's A. And then first, I'm going to get the cumulative exclusive OR result. So this is in parallel to the previous video. So here, so I can use accumulate this function. So the iterable we're going to use is A, and the operator or the function we're going to use is the exclusive OR. And also we initialize an initial as to be 0, right? Then this gives you an iterable, so you can make it a list and make a print for that. So let's print out this one. So if this will be the same as the pre, so it's the pre in previous video. Right. So let's print that. So we should have 0, 1, 3, 0, 0, 1, 3, 0, right? So with these preparations, now let's look at the major function. So I'm going to write a function that's called dp, so I, right? So in other words, I want to split the first I element into key subarrays. So here, first, if k equals 1, right? And then the result will be just the previous I element. So and just use return the pi, right? So notice this indexing. So the first 0 element, so if you think I equals 0, so you get P0, it's going to be 0, right? Think of this one. Let's print out this. So if P0, it should be 0, so first 0 element. The first 1 element, you get 1. First 2 elements will be 1, 2, you get 3. First 3 elements, you get 0, right? It's exactly corresponding to the index due to we use this initialization. In other words, the length of this P is 1 longer than this one, right? So you see here the length is 4, starting with this 0. So with that said, now let's look at another case. First, also we make an answer that is infinity, right? Corresponding to the DP update in the previous video. So then for the previous elements for making k-1 subarrays. So J in this regard is at least k-1, right? And then up to this I, right? So because we cannot use up all the I element, because otherwise then the current last subarray will be empty, right? So then the answer will be the same format as the previous video. First, I get the max dp. So for the J element, I partition them into k-1 subarrays, and also with the result for the current one. So the current one is the first I elements excludes the first j elements, and j is less than I. So it's exactly pj exclusive OR with pi, right? So here we are actually using the cancellation property of the exclusive OR. The reason is that pi is the first ith element result, so exclusive OR with the first ith element. So let's use 1 indexing, right? So 1 and 2 up to I. Then pj, if we use 1 indexing, is the exclusive OR result of the first j elements. So notice that here 1, 2, 3 up to this, not the real the number itself, but the corresponding index for representing the elements. So then if you do pi exclude OR with pj, so due to the cancellation, it will be the so from j plus 1 up to I, right? So this is exactly what we need, because the first j element is used in this k-1 subarrays. From the j plus 1 up to I element we are using in the last subarray. So this will give the max corresponding to this partition. But we want to find the mean, so we want to do answer and this and the mean. Right. Now we just need to return the answer. So this is the major function, but here we need to use some cache. So at least the reason use cache. See. Now what we are going to do is going to call dp. So we get the length, the end element, make key partitions, right? So also you see why we change this to be capital key, but you don't need to change this nums to be a, but change it to be a capital A saves some typing. So now first let me run it. It passes the 3 test cases. So now let's look at the generic case. Yeah, it passes all the cases. So here, by now we have finished explaining the problem using 2 videos. In the first video, we are using tabulation, and in the second one here, we are using recursion. So in the ultimate sense, these 2 videos explain the same solution thought process, but the code's formats are different, I guess. So it's actually good to practice both the 2 formats of solutions. So actually, sometimes the coding formats matters, though they are essentially the same. Because for one format, it might be easier for you to write, while for the other, maybe you're not very accustomed to, right? So with that said, that's the end for the second video. Finally, I want to mention that in our YouTube channel, by now I guess we have more than 1,000 well-prepared and rigorous explanations about YouTube problems, leetcode problems, and we classify them into different playlists, so to help you practice. Hopefully this YouTube channel can bring some useful information to you. With that said, that's it for the current video. Thank you.